Alright, so this lesson 10.7 is all about circles and sectors. So, circles and sectors. So the first thing we're going to do is just review the area of a circle. So area equals pi times r squared. Alright, and remember that with orders of operations, you have to do the r squared part first. So do first. Then you multiply by pi, okay? So it's important that you do the r squared part first. So here's my circle. We're going to call this circle O, and it has a radius of r. Okay, circle O has a radius of r. Right? Example 1. If I give you, it has a 6 meter diameter, and I want to know the area of the circle. So area equals pi times r squared. So remember that the radius is the distance from the center of the circle to the outside edge. So that would be half of 6, so 3 and 3. So this distance is 3, and that's my radius, right? So I'm going to plug that into my equation. A equals pi times 3 squared. We have to do that first. 3 squared is 9 times pi equals. Now, most of the time when you're dealing with area or radius, you leave your answer in terms of pi, meaning that you just leave it as 9 pi. Remember, we've talked several times about how it's just more accurate to say the square root of 2 than it is to just plug it into the calculator and get some really long decimal that you then have to round and cut off because you've sort of made it less precise. That is exactly the same thing that happens with pi. We know that when we plug pi in, it goes on and on and on forever and ever and ever. So anytime you give an answer, you're going to have to estimate it to some degree, and you've lessened its accuracy by doing so. Therefore, we try at most times to leave your answers in terms of pi. And that means that you just don't multiply them together and give me the decimal answer. You just leave it this way. How many pi do you end up with in the end? Okay? So, in terms of pi, you're going to see that written a lot. It means to not multiply. So, it means not multiply and round. Don't do that. It means leave it in terms of pi. So this is in terms of pi, 9 pi. Okay? Question number 2. Some farmers use a circular irrigation method. An irrigation arm acts as a radius, so that's good to know, of an irrigation circle. So I have 2 irrigation circles with the radius. The irrigation arm is acting like a radius going around. So I have 2 of those. Okay. How much more land is covered with an irrigation arm of 300 feet than by an irrigation arm of 250 feet? So this one's 250 and this one's 300. So they want to know how much more land is covered. Okay. So they want to know the area of each of the circles. So area equals pi times 250 squared, right? And area equals pi times 300 squared. So this one, 250 times 250 gives you 62,500 pi, because this is 62,500, and then we have to tack on pi. And then this one is going to be 90,000 pi. The question is how much more land is covered. So we have to take the difference. 90,000 pi minus 62,500 pi. And when you subtract, you're going to get 27,500 pi. Well, look, if we're talking about area of land, we can't give the answer in terms of pi. That doesn't help anyone. So you have to do 27,500 times pi on your calculator, and you're going to get 86,394, and since it's area, it's feet squared. They gave it to us in feet. Okay? So in that one, we couldn't give the answer in terms of pi. It said how much more land is covered, and so that wouldn't have made any sense. All right, question number 3. Let's scroll the page up. So these are just questions that we're just going to practice using or finding the area of pi. So what is the area of a circle? What is the difference in the areas of a circular table with diameter 6 feet and a circular table with diameter 8 feet? So 6 feet and 8 feet. So remember, we need the radius to find the area of a circle. So I want this, which is 3, half of 6, and I want this, which is 4, half of 8. So, and again, the difference is what they're looking for. So area equals pi r squared. I have two of them. I have the area of pi times 4 squared, and I have the area of pi times 3 squared. 4 times 4 is 16, so this is going to be 16 pi. And 3 times 3 is 9, so this is going to be 9 pi. If I want the difference, I'm going to subtract. And 16 subtract 9 is 7 pi. And again, we're talking about feet here, so we do have to multiply that out. 7 times pi, roughly 22 feet squared, because we're talking about area. Okay, so that's how we use the area formula. Now we're going to talk about the sector. Okay, the sector is like a slice of pie. You can see this is shaded in because I want to know the area of just that slice, not the whole pie, just the slice of pie. And so let's think about what our formula might look like if I want to just have the area of just that slice. Okay? So again, I just want a piece of the whole area. So I need a fractional piece. This is my fractional piece of the whole pie. So fractional piece of the whole pie. Okay, fractional piece of the whole pie. So, fractional piece. How many degrees out of 360 degrees? That's your piece. Okay, times, and we're talking about the area. So I just want this fractional piece of the entire area, and the area of a circle is pi r squared. So we're going to find the area of the circle, and then we're going to multiply by the fractional part. Let's try it with this one. So I have 72 degrees, so I need 72 out of 360 degrees. That's the fractional portion that I want of the area, pi times r squared. So remember what I said about your calculator in this one, right? It's going to make a lot of sense for you to go ahead and multiply across the top and then divide by 360. So a lot of times we give the answers to these also in terms of pi. So here's what you're going to do. You're going to leave the pi out for now. You're going to do 20 squared, multiply by 72, divide by 360. When you do that, you get 80, and then you just tack on the pi at the end. So I did 20 times 20 to get 20 squared, multiply by 72, divide by 360, and just drop down the pi. So I get 80 pi. All right, in terms of pi. In number 2, let's do the same thing. So again, I want a fractional part. So this time I want this giant fractional part. Well, here's the deal. This is a 90-degree angle. So I need to know how much this is, right? And that's going to be 360, subtract the 90 that's in white that I don't want. Okay, and that leaves me with 270 degrees for the shaded region. That's 270 degrees. So I want 270 out of 360 of its area, pi r squared. Again, if you're going to do it in terms of pi, you're going to do 4 squared and get 16 times 270. Divide it by 360, and you're going to get 12, and then you're going to just drop down the pi. So 12 pi is your answer. So that is how you find the sectors of a pie, so the slices of pie. But we're going to turn it up a notch to make it just a tiny bit harder with the next section, which is called finding the segments. So now what we've done is we've taken this slice of pie that we're dealing with, and we've sort of cut it off. So it's as though I cut myself a piece of pie and then part of it stuck in the pan, and I only got that shaded section out of the pan. That little middle triangular section stuck in there. So I need to do a couple of things, and here's how we do it. We find the area of the whole sector, okay, that's what we call it. So we do the sector, and then we subtract the triangle. And what's left is what we call the segment. Okay, so let me color code this for you. The sector is in red. So it's sector, subtract the triangle, which is in blue. So subtract the triangle in blue, and it leaves you with the segment in green. There's your segment. Okay, so the whole slice of pie, the sector, subtract the triangle, leaves you with the segment. Here's what your formula looks like. You need your sector, so you need x degrees out of 360 degrees times the area, pi r squared. That's your sector. Minus the area of a triangle, which is 1/2 base times height. Okay. Sector minus triangle equals segment. Okay? So, sector minus triangle equals segment. And these are going to get a little tricky as we get going, but let's try these first two examples. So, I'm going to do sector minus triangle. Okay, so the sector is 90 degrees, there's a 90-degree angle here, out of 360 of the circle's area, so radius squared. So there's my sector minus the area of the triangle. So let's just look at the triangle. 1/2, the base of the triangle is going to be 10, and the height of the triangle from the center to the outside edge, well, if we just said this was the center to the outside edge and it was 10, then this from the center to the outside edge must also be 10. So base is 10 and height is also 10. So this one works out fairly easily for us. So we're going to multiply over here. 10 squared times 90 divided by 360 gives me 25 pi, okay, minus 10 times 10 is 100, and half of 100 is 50. And then I'm going to do 25 times pi, and I'm going to get 78.5 minus 50, and I get an answer of 28.5. So when you're doing these problems, I usually say round to the nearest tenth. Okay, each step round to the nearest tenth. All right, let's try one more of those before you go start practicing some of these. So here's example 2. So again, this time I want the shaded region that is underneath. So this is a sector. So this is my sector, okay? That's my big giant slice of pie. So I was really super duper hungry. But then I also have to add to it this time the triangle. So this time I'm adding the triangle. So we're sort of doing the reverse, because everything that, see, in the first one, the only thing that was shaded was the segment. But this time everything other than the segment is shaded. So I need this sector, the big giant piece of pie that looks like Pac-Man, and then I need the triangle added to it. So this time I'm going to do sector plus the triangle. So the sector again. So this is 360. So the full circle, 360 minus the 90 leaves me with the 270. So that's my sector, 270. 270 degrees out of 360 degrees times the area, pi times radius squared, plus the area of the triangle, 1/2 the base, which is 18, times the height, which is going to also be 18. Because remember, the distance from the center to the outside edge, if that is 18 over here, then it has to be 18 over here as well. So again, 18 squared times 270 divided by 360 is 243 pi plus 18 times 18 and take 1/2 gives you 162. 243 times pi is 763.4 plus the 162 for the triangle gives me a total area of 925.4.